Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And I'm Philip Sage with the Manaway Group in Australia.
Hey, Philip. We finally figured out the time zones. We did one dry run and it kind of worked. And then I show up late to this one, so thanks for hanging in there with me.
No worries.
But I was in a discussion earlier today, and I've seen it other places, and I wanted to bounce it off you. And it's more of a question of, yeah, it happens, but what do you do about it? How do you help people get past this thing? And so I'll do it hypothetically. So let's say somebody figures out that CPK is the bestest thing ever invented, and it's helped them solve problems in the company they used to be at, and they have black belt experts at setting up process control studies and go in depth on it and do all this stuff. They figure out their critical parts, and they get the CPK values, and they figure out all these details and process capability for those. And they're doing an excellent job at it. And so she moves to a new organization, and they're not doing any control chart stuff. And she says, that's why you have a problem. You need to get really good at control charts. The discussion then went into that whatever it is that team needs to know how to do, they need to become experts at it. So I think there was a nuance there, is that good enough is not good enough anymore. You have to be the expert in whatever tool or technique you use. And I think there's some argument for that. And then another point out of that was you don't lead your reliability program with the tools and techniques we use. I think that's backwards. It should be from, what do you need to know? What information do you need to make better decisions? And then what tools and methods can help you get that information? But part of it, the first thing that struck me was, I'm really good at process control, so everything looks like a process control problem. It's a tool, it's a method in search of a problem kind of thing.
I think it's important to use the right tool at the right time, and not one size fits all in every reliability improvement type effort. It's the real question is, how good do you need to be? And in today's competitive market, that may be quite good in certain segments. In other areas, it's not all that important. And even when we go back to reliability-centered maintenance, one of the default strategies is to run it until it breaks and change the part. So as good as you need to be is probably making sure that your storeroom has got auto stocking on those parts that you've decided to run until they fail, so that you don't get caught kind of with your pants down into a pre-planned emergency. But if you're going off the deep end all the time and doing modal analysis study and vibrations and instrumenting up every piece of equipment that you make with triaxial accelerometers and recording and understanding how it moves and shakes. Well, that's good information. But the question becomes, in my mind anyhow, do you need to? And a case in point, when I go look back in my career, which, gosh, it started a while ago, didn't it? But laser alignment was just coming out as a new fangled tool, the early version 1 laser alignment. Today, it's much more simplistic and video game-ish, perhaps, is a way to oversimplify it. But we put the laser alignment and the engineers who were doing all the calculations to make that work up against a couple of old 42-year veteran craftsmen using key stock and feeler gauges. And guess what? The old guys won. So, it's really the hidden lesson in that is not how close do you have to get, shaft alignment. And we all know, at least many of us believe that is, in fact, very important in the modern world for machines that have rotating equipment. But did we need the technology that we used. Now, granted, using feeler gauges and key stock and those old manual techniques that had worked for hundreds of years probably was hard taught taught by learning by trial and error. And today's laser equipment is incredibly easy to use. Make the adjustments, put the right number of shims underneath, tighten things down, and spin the shaft once, and you're pretty much done in a short period of time. So it's a question of, in my mind, when you look back at it, control chart type of topic, and saying, I've come from a heavy user of control charts, and I'm now in a new organization, and the reason that they're having problems is there's no control charts. The question in my mind is, do you need them? And
Right.
and if you're in the manufacturing process where you have critical tolerance problems, then you probably do need them. And some of the most effective control charts were actually, in my career, were the ones that I drew with a pencil and
Oh,
plotted the
I'm
points.
still an advocate for that.
Yeah.
It's
So, yeah.
sending it to a server someplace and nobody looks at for 2 weeks is less than useful.
Yeah. Yeah.
Yeah, but I think you're onto something there, though. It's the, I mean, do you need to use it? And I think that's where I'm coming from too. Is that,
Mm,
well, what is the actual problems? And I mean, you can make perfectly capable products to meet your design specifications, but if the design specs are just horrible to start with, that it will consistently create a bad product.
mm.
Right. And so
Yep.
that's probably why they didn't bother with control charts. They may have done it for a while and, well, this is easy, no problem. That's not solving our problem in the field. And so the um, part of it is, and I think you phrased it just perfect, and I wrote it down so I remember to put it in as a title, is the right tool at the right time. And I think there's a third dimension, is the right level of application of that tool.
Mm.
Because
Yeah,
not every problem is a very complicated, detailed PhD level series of design of experiments. Sometimes you just need an hypothesis test and move on.
I agree. Yeah, I look back at all the different challenges I've had through my career, and when I've led quality efforts and improvements and trying to understood oil field compressors that were blowing up and destroying themselves and why those things were happening. Sometimes it's a very simple hypothesis and a test to see if you're on the right track. But there also have been a few times where we've had to, go the route and finally, break down and do a full blown modal analysis because we couldn't see with human eyes and senses, or any of the instruments that were built into the machine. We couldn't see what was causing the problem, and we needed more. But
Right.
it's
But
few.
you go into the problem and analyze non-destructively and what you can do, observe what you can do in 5 minutes, those kinds of things. And if there's an obvious issue with that, and it makes sense to cause the problem you're seeing, then let's go adjust that and fix it. But if that's not working, then what you led with, though, Philip, was we need more information. There's something we're not seeing. Right?
Correct.
What other
Correct.
tools do we have? What other techniques do we have? And the hard part I see in many organizations, and it's independent of all these different tools we're talking about and techniques, is the awareness of the range of available technology. Not just that there are control charts, but there are actually control charts for small small runs, and there's control charts for nonlinear stuff, and there's control charts with offset sides of their dimensions or capabilities and stuff like that. There's a plethora of different styles of things you need to go do, and some are constrained by, do you have attribute data or variable data, but some of them are, how sensitive do you need to be?
Mm-hmm.
Right?
Mm-hmm.
It's, what are you actually trying to solve here? And part of it is, to me, it's awareness of, and I think I've collected, at one point, a colleague of mine said, oh, to be a good reliability engineer, here are the 600 different things you need to know about. And it was everything from hardness testing to X-ray equipment to chemical analysis and all these
Mhm.
different fields and control charts and all the other stuff that goes with it. And I think he's about right. We touch, depending on what you're working on, you
Yeah.
may, have a subset because that's what's in your industry and your product. But in consulting, we run into all kinds of stuff. I'm thinking
Yep.
of my first real experience into it was with inkjet printers. Um, I learned about plasticizers there because
Hmm.
the little pick roller was a improvement in manufacturing. Instead of a shaft and then a roller put over it and a screw to fix it in place, they made it in one shot. They put this shaft into a mold machine and then molded uh, the the little rubber-ish roller thingy that it was
Hmm.
a pick. It was tacky enough that it would pick paper up off the top, but not
Hmm.
too tacky. It would wrap it around it. So it was kind of a cool surface.
Perfect.
And they said, oh, we'll just mold it in place rather than have this screw. And it was just a simple cost reduction, make it quicker, easier. It's one part, not three parts. It all makes sense on the chalkboard. Well, in order to mold it, they had to add a plasticizer to it so they could get it out of the mold. And when they pulled it out, they put it in a printer, it worked beautifully.
How about that? Yeah.
Right. And then about a week later, or 2 weeks later, or a month later, that plasticizer blooms to the surface of the surface and makes it pretty much like Teflon, very slick.
Uh,
But if you use the printer all the time, like
hmm.
in some of the testing they were doing, they're running hundreds of thousands of pages through these things. It would knock off the little bit of blooming with every page. Every piece of friction would rub it off. But if you let it just
Hmm.
sit for a couple of weeks, it blooms and it creates this surface. And then there's a long story behind all that, but it was like, I've heard of plasticizers before. I used to work in a polymer company, so I know a little bit about polymers and stuff like that, but I didn't know anything about molding. But once again, I learned something and then moved on to it. And so when I
Hmm.
have one of these tackiness type issues, I ask those questions. But that's the craft guys that you were talking about doing shaft alignment. They did it
Mm.
15,000 ways and it didn't work. And they learned from each one of those so they could do it very quickly and efficiently most of the time and get it right.
Mm.
Whereas if you didn't have that 15,000 sets of experiences of it not working, you wouldn't know.
Yeah. Reliability is a field that, and especially considering the different interpretations for what a reliability engineer does, from anywhere from a maintenance firefighter and a glorified maintenance engineer through the quality and product development
Mm-hmm.
phases, as well as the equipment and asset management aspects of reliability. The number of tasks, now the types of information, the types of equations that you apply, is it's mind boggling, and it's one of these fields that I know that I'm still learning, but I think it's one of those fields that it's pretty much guaranteed you're never going to know all of it.
Oh,
It's
yeah.
it's just too big.
There's too many people inventing new materials, new processes, new techniques, new tools. And I think this is somewhat related to what I call the shiny object syndrome. You remember,
Mm,
the Internet of Things, where everything was going to be interconnected and everything would be collecting data.
yeah,
They forgot to mention somebody actually has to use it for some valuable purpose. It doesn't,
yeah, yeah,
you know.
yeah.
And then there's the Internet of Things, and there's digital twins, and there's, I had in the product reliability side. Unfortunately, my book hasn't really caught on, so that people are doing the process of reliability, but it's too common sense. I think it's not flashy
Yeah.
enough. But the idea is that it's some of it is that this guy worked in a successful company and says, "Oh, this is the way you do it," and then moved into a new company and says, "Oh, that's not here. That's why they're not successful." And like that's the challenge, I think, between awareness and capabilities and so on. But shifting the mindset from, but I always use this wrench to,
Yeah.
is it the right tool for what I'm doing right now?
Yeah, I think and it's very important, especially to understand and be honest. When you move between companies, you're going to one of a couple of things is going to happen. You're going to move from a something, one, two, three, four quartile company to a lateral move to the same level, or a move to a better company that does things that you've never been experienced with in your professional career. May have heard them, may know a little bit about them on the sides, or what seems to be more common is you move into a situation where the new company is not as good as the old company that you came from, and there are things that could be of benefit, but again, is it the right tool at the right depth and at the right time for the organization to absorb and internalize and then to begin to adopt. All of those things I think are very important. And often we look at all the different tools and technologies and software and we forget about the people.
Yeah. And I mean, it goes into a whole nother topics for other discussions, but the area of change management and all that stuff really applies. But when you mention you move to a company that's not as good as where you used to be, and when we get that in consulting, just that's the
Mm.
nature of our work. They expect us to know better.
Every
There's a bit,
couple of weeks.
yeah. And some of them expect, or some of the companies I've walked into as a consultant originally weren't doing all that good and did a little bit
Mm.
of work with them. They got their marching orders. They went off and then they called me back 5 years later and they were much better. Everything they were doing was pretty darn close to, I couldn't find any. It was a nice challenge to have to figure out. There was the way the story went is they held up a piece of paper and says, here's our decline in field service calls. And it was something where they
Mm.
leased units out. And here's where we called you the first time. And we saw this go down and we plateaued. And then we called you to get some improvement.
Mhm.
And so I said, well, so what's happened since then? It was, well, I thought he was showing me the same chart. It was just the scales were different. It was, we went down another decade-ish of improvements
Mhm.
and it's flattened out again. Now what do we do? And I thought, they got their act together. They're looking for this continuous
Yeah, yeah,
improvement thing. And I asked, is this still a major issue and stuff like that? And he goes, it's not the most major issue, but we have so much focus on it. We want to get another round out. It's in the top three most important things for us. And there's other teams working on the other stuff. And I'm like, okay, cool. But that was a real challenge to hone an already good system. But one of the things that I learned early on in my consulting was you have to start with where they are.
mm,
If they've never heard of process control and control charts and using that in setting tolerances or picking components or doing their design work or making process improvements on the floor, you got to teach them the basics. Let's do an X bar R chart on an experiment on one piece of this and just learn how to do it. So let's see if it's useful. And then build off of that and build successes, build some expertise in a few people so they became known as the experts. It just saying, oh, you need to do control charts and walking out, it would have been a non-starter because
mm.
they didn't know the basics of the theory of it or the math of it or the understanding of what does this signal actually mean and where does this come from and stuff like that. So whatever the tool is, like FMEAs, if they're already got a process in place and they're all very familiar with it and they understand the FMEA process and you're facilitating it, use their process, use their
Yeah,
spreadsheets, use their stuff, But if they've never heard of it before, you get to introduce a new one for them and spend time to explain it, go with it. But to come in and say you need to do modal analysis on high end vibration to do all this work, eh, yeah, I don't think
yeah,
that's going to work. But anyway, that was the topic for today. For my one thought here is that, in summary, and I might be repeating my own concerns a little bit. I think we agree a lot of this stuff is that I'm going to steal that right tool at the right time. Maybe I'll get some T-shirts made out of that.
right.
but it's also the right depth. I think that's the
Hmm.
dimension that's also missing is if I can do a simple, quick tool and make progress on solving the problem, do it. If it comes with the caveat that you know that that's going to give you the information you need, or that's going to cause the results you're looking for, and it's good enough, go for it. If you need more expertise, get it. But
Hmm.
but just because you have the expertise doesn't mean you have to use it.
Correct.
So I think
Correct.
that's where we're at on it. All right, cool. I knew you'd agree with. I was hoping you'd agree on it because otherwise I was in deep trouble. But if
Yeah.
you've got a comment or a question on this, uh, and what we didn't get into development, we're going to come back and talk about is how do you break that cycle? How
Mm.
do we systematically get that out of an organization? But the idea is that if you're listening to this and your head's nodding and or you've got stories about this or you hear stuff about it, let us know. Or if you got a question on a different topic, we always love those. Head over to accendoreliability.com/go/SOR. And you can find a couple of ways to get in touch with us. Philip and I and the other hosts of the show are available through LinkedIn and our About pages. So we're always looking for good feedback and comments. And, when you say nice things, that also helps a lot too. So appreciate that. So with that, Philip, I think we'll wrap this one up and see what else we can talk about.
Fantastic. Nice job, Fred.
All right. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.